everybody. So the first lecture is about limit of the function. Limit of a function. So first thing I want to remind you what a function is. So this is an idea from algebra, so again I expect you to have already studied it somewhere and know well, but I will still remind you. So what is a function? Function is a rule in mathematics that allows you to use to substitute some value into that rule to do some operations and come out with resulting value, which we call value of a function. Like for example, think of a tax table. So you come with your taxable income, put it into the table, do some operations, and then come out with the tax. So the tax is the result of your function. So that's an idea, and in mathematics very often functions are denoted like this, f of x. And typically f of x, function like f of x is defined with a formula. For example, f of x equals x squared minus 2x plus 5, whatever. And then the idea of a function, once again, is that we can plug in certain values for x, pretty much any values we want. For example, plug in x equal 1, and then we write f of 1 equals, and then just replace x with 1. So 1 squared minus 2 times 1 plus 5. 1 minus 2 is negative 1 plus 5 is 4, and that's it. So that's the function value. So function value. So that's the idea from algebra, and now I will explain you what the limit is. For this, first of all, I want to use a different function. Different example. So consider function, the following function, e to the power x minus 1 divided by x, where e is one of main constants in mathematics. Hopefully all engineers know this, so if not, so I remind you it's approximately equal to 2.7. In fact, it's an irrational number, so it has infinitely many digits. So it's 2.7 to the x minus 1, all that over x. Now, you can tell that there is definitely an x value that you cannot plug in. Specifically, it's x equals 0, because you cannot divide by 0, so you cannot plug in x equals 0 in that function. However, we can plug in some other values. So I don't want to plug in arbitrary values like x equals 5 or 10 or whatever. So I want to plug in, so let us plug in several x values. Which are close to 0. So we cannot plug in 0, so several x values which are close to 0. Of course, close to 0 just means small, so small value, so small. And moreover, every next x value that I want to choose will be smaller than the previous. So every next x value smaller than the previous one. Now, exactly how to choose those x values is not really that important, but I will choose the easiest. For example, the first value will be 0.1, 1/10, which is pretty small. The next one will be even smaller, smaller than 1/10, what, 100, 1,000, 1/10,000. I mean, we need to stop somewhere, so I will stop it there. And I want to plug them all into this function. For example, to plug in x equals 0.1, 1/10, it will end up f of 0.1 equals, and then of course I will replace x with 0.1. Everywhere x, so we have two instances of x, we replace them both with 0.1. So e to the power 0.1 minus 1 over 0.1. And of course we need calculator to calculate that. I will use my calculator TI-84. And remember to use parentheses, because either you use fraction feature on the calculator, or if you type it all in one line, which is more convenient, but you have to remember parentheses. So e to the power 0.1 minus 1 in parentheses divided by 0.1. To calculate this, of course, we have to use calculator, and my calculator is TI-84 Plus, which is most popular among students studying calculus. So I will do this. Open parentheses, e to the power 0.1 minus 1, close parentheses divided 0.1 equals, and here I got the value, which is 1.0517 approximately. In fact, it has infinitely many digits. So that's the first function value that I got. Now, of course, now I'm going to plug in all of those x values, and you can see how much work it takes to plug in even a single value if you just do it straightforward way, just typing in the entire formula. So I want to use a special feature of the calculator. This feature is called table. So I will not really type in formula for each x value that I want to plug in. So I will use the table feature. In fact, this calculator has many useful features, and right now I will use this one, table. So here's how it works. So first of all, you have to set it up. You have to press second table set, and then so you press second table set. And on the screen that you get, it's table set up. On this table, on this screen, you have to set up, look only at the last two lines. They are labeled independent. So I will use the table feature of the calculator. So table feature. And I will explain in short how this feature works. First thing you need to do is you need to set it up, and you only do it once after it is set up, so it will stay that way until you change it, so you don't need to touch set up anymore. But just first time I explain it, you have to press second and then table set up, table set, and when you do it, so on your calculator, you will see a screen like this. Table set up, and there are several lines here, so you look at the last two lines. So the last two lines are labeled independent and dependent. Independent is actually named for x. Independent means x, and dependent is named for y. And they both are switches, so they can switch between auto and ask, and previously they both set on auto, so by default they both are set on auto. I want you to set x on ask, so ask will highlight, and the y stay on auto. So what this means for the calculator, it means that calculator will ask you for the x value, and it will automatically calculate the y value, which is same as the function value, and that's precisely what I mean. So independent set on ask, dependent set on auto. After that, you want to press y equals and actually enter this function that you want to find, that you want to calculate values. Such as press y equals and enter this function. Again, remember to use all the proper syntax, such as e to the power x. Now use x minus 1 in parentheses divided by x. So second ln for e to the power, then x minus 1, close parentheses divided by x. After it is done, then you press second table. Second table. Table is located above the key that is labeled graph. So if you press second first, then it will show table instead of graph. And now in this table, if this again by default this table is clear, but if it's not clear, so you press delete to delete everything. So this table looks like this. X and then y1, because that's how we entered our function. We entered our function against y1. In fact, the calculator is capable of saving 10 or more functions. We only need one. So, and here's what you do. You enter any x value you want, and the calculator will automatically calculate y value, put it here. So I enter 0.1, press enter, and I have 0.1, and calculator automatically calculates 1.0517. This is precisely what I already did, so it's no new information, but right now you can put any other x values, like I said, 0.01, and press enter. 0.01, press enter, and the answer is 1.005. 0.0001, 0.001, enter. 1.3075. Let's try one more, 0.4071, enter. As soon as you do that, 0.3071, by the way, this number doesn't look like this on the calculator screen, it looks like 1e-4. It's so-called engineering format for numbers. It means 1 times 10 to the power negative 4, which is the same thing, 1/10 upwards. And the function value is 1.301. Okay, now I will not go any further, so I want to observe the corresponding function values. Like when I plug in x values smaller and smaller, what happens to the function values, to the y values? If you look from the top down, you will see that those function values become closer and closer to number 1. So let me write it as an observation. Observation. As the x values that we chose and decided to plug into this function come closer and closer to 0, so the corresponding function values, which are in this column, function values come closer and closer to number 1, because 1.05, 1.05, etc., so they come closer and closer to 1. And this number 1, where the function values come closer and closer to, this number actually plays a very important role in mathematics, and exactly this number is the result of the game, so this is limit of a function. So this number 1 is called limit of the function. And now I want to explain mathematical notations. How do we explain how do we write this down using mathematical symbols and everything that to make it shorter. So first of all, coming closer and closer, you may use a shorter word such as approaching or tending one. So we can say as x values come, I should say in plural, x values come closer and closer to 0, so the corresponding function values come closer and closer to 1. So let me write it in short. Like I say, coming closer and closer, we can say approach or tend. So we can say as x values approach 0, so the corresponding function values approach 1. We can make it even shorter if we use some mathematical notations like this. X values, they approach often denoted just by arrow. So as x values, as x approaches 0, so f of x approaches 1. So this is pretty short notation and it's quite clear, but there is even shorter mathematical notation which is commonly used in calculus. So here is the math notation. For the limit of a function. So we put three letters L, I, M, that mean limit. Now beneath these three letters we put in smaller size and smaller font, so to say we put x arrow 0, x approaches 0. So its limit is x approaches 0. Now next to the limit notation we put either formula that we have, for example, e to the power x minus 1 over x, or we can put just f of x. And then we put equal sign, and to the right of the equal sign we put the answer, which is actual numerical value of the limit, which is 1. And so this is the notation for the limit. So we read this formula like this. So read limit as x approaches 0 of this function e to the x minus 1 over x equals 1. Equals 1. Now, of course, we can use a more general notation because x doesn't have to approach 0. In fact, x can approach any other number. And also the answer of the limit doesn't have to be 1, it could be any number. And so general notation would be so we still have LIM. Now x approaches. Now instead of 0, we typically put letter A. This letter means the number where x values approach. And typically this number is given. Now, instead of this expression, we just put f of x. Again, it's a given function with a given expression. And then equals, and again, the answer doesn't have to be 1. It was 1 in this example. In a different example, it could be something else. So it's denoted by L for limit. So this is the general notation. So this is limit of a function. Now, one more thing I want to say regarding the previous example, regarding this example. I only tried x values that are closer and closer to 0 or approaching 0 only being greater than 0, such as 0.1 and 0.01 and 0.001. In fact, it's a little bit of cheating. I only did half of the job. I also need to try some x values which approach 0 from the other side. In this case, it would be from the negative side, which means I need to try x values. So I will restore the, need to also try x values, need also to try x values approaching this value 0 from the other side. Like what? From the other side means approaching 0 from the other side means approaching from the negative side. And that means, for example, it could be negative 0.1, negative 0.01, negative 0.001, etc. And now I want to do the same thing with these x values, which means I want to plug them into the same table. So I go again, second table. So second table. Now I don't need to set up anything because everything is already set up. I want to copy it again here. So it was x, y, 1. So what I previously had, it was 0.1, 1.0517, 0.01, 1.005, 0.001, 1.305, 0.0001, 1.301. So now the other half of my, let's call it numerical experiment, should be to plug in negative x values. But those negative x values will also approach 0, which means they will also be smaller and smaller, except they will approach 0 from the other side. They will be negative and small. I already said negative 0.1, negative 0.01, negative 0.001, etc. So if I do that, so negative 0.1, the answer is actually quite different, 0.95163. When I plug in negative 0.001, oh sorry, first I want negative 0.01, then the answer is 0.29502, and I will try one more, negative 0.201, the answer is 0.305, 395, and again, once again, we watch these numbers and we say that they approach 1, and we watch these function values and we see that they also approach 1, even though they are smaller than 1, but we don't care. I mean, we do care. What we care about is that these values also come closer and closer to 1, so it also approaches 1, and therefore we have just checked this limit on both sides. So this is called numerical method, and we have solved this limit numerically, and the answer now we 100% know that the answer is 1.